All right, as we do on Mondays, we're going to check in with our course outline. We are on April 23rd. We're in week 13 of a 16-week semester, 15 week of classes, 1 week for finals. So this is what it looks like for this week. We finish up our student presentations, and we're going to get introduced to digital painting. Digital painting is, in many ways, the most straightforward version of digital media that we're learning, where you just control every pixel and you make it for yourself in the program itself. We're going to learn how to make our own brushes. We're going to learn how to layer up and try out different techniques. But you need to pick your subject matter. And so that's what we'll focus on getting you ready for, so that we have a work day on it on Wednesday, on April 23rd. Then we're going to have a question of the day, which is about artificial intelligence in image generation, validity, authorship, and the problems that digital art has with this that traditional art doesn't, right? And then we start on Monday with our final assignment, right? It's assignment 8 for you, but think of it as just your final project. It's worth 10 points instead of 3 points. It's based on a theme that you can already look up under assignments. And it's called conceptual because all I do is give you the theme and you decide what techniques in digital imaging and media you want to use to create the project. That project incorporates Proving Ground number 4 as our way of ideation, of sketching for it, of creating thumbnails, and then working with me, the instructor, on improving that idea rather than posting it and getting comments from students. So Proving Ground 4 is kind of a particular way of improving your idea. And then April 30th, we have a work day on it, and as part of Proving Ground 4, that's when we'll have individual process critiques, so a very important day to be present and be working on your final project. It's also when you're going to be selecting your final portfolio projects, if you need to print any others, like your poster. Your final project will definitely get printed for our final gallery critique. And then by May 5th, we're hoping to print these. Print your final portfolio pieces, your finished posters, your spot illustrations, anything you improved from the first half that you want as part of your 5 print portfolio minimum, and your final project, right? So a lot of the focus is going to be about finishing off your work and then printing it. So this video, which is kind of a special video, is to cover professional commercial printing. So if we look at our assignments so far, we've only printed 3 of them. And we did that for the midterm critique. And we printed with fine art printers, which actually have 9 different inks with different glosses, different opacities, and they put out 2,600 something dots per inch. Professional offset lithography presses do not do that. So if we look up commercial 4-color offset lithography, this is how most things in the world get printed. These are printing presses. And basically there are 2 types. There are the type that do commercial grade, which is 300 pixel per inch images to inform, but that's on clay-coated paper, right? And then there are types that do newsprint, which run way faster, but only require about 150 pixels per inch because it's paper that's much more absorbent. So this is what they look like, and they run fast. So if we do a quick little video, so that is what the speed of a 300 pixel per inch, kind of commercial grade paper, think glossy magazine, think poster, think your textbook. That's how it runs. We don't really need the music. Let's see if we can look at a newspaper run. Now, if a newspaper is only running black and white, it can go so much faster. And they can be really loud. I don't know if this will quite do it, but there you go. So he's putting it out. So that's one color, but that's just the yellow, and then they would run it through again and again and again. Yellow is the base color for CMYK. So in order to understand this, we are going to look at the last project we did, assignment 6. I'm just going to open up my JPEG that I posted. All right, let me see, did I already do? Yeah, I already did color separation on that one. All right, so this is the project as finished in the class, right? And then that is on the right. And then on the left, you can see it overlaid with what's called CMYK color separation. And that is what it would look like if you took a magnifying glass to it and it was professionally printed in a commercial way on these offset lithography presses. So very different than our fine art prints. So this is how I'm going to show that to you. If you go to your assignments, tag this, and you scroll down, we don't even need to click on it in particular, but underneath assignment 6, these are our supplemental, helpful materials. And I give an exhaustive explanation of CMYK color separation. And this is something that will be on the final exam. It is something that's in your learning outcomes. You need to understand it. You don't need to be able to use it. You don't need to be able to separate, but you need to understand what it is. So this is taking any full color image, and how is it printed professionally? It's only printed with 4 inks on white paper. And those inks are cyan, magenta, yellow, and black. And why do they use K for black? They don't want it to be confused with B for blue, right? Because there's a big difference between RGB, which we'll talk about, and CMYK. So RGB is how our computer screens see color. It's actually how our eyes see color. These are the light primaries. So when you're using light, in order to see the millions of colors on a computer screen or on any device, it uses red lights, green lights, and blue lights at this frequency of color. So notice that that green, that red, that blue look very different than the ones inside here. When you combine these lights, when you combine red light with blue light, you get magenta. When you combine red light with green light, you get yellow. And when you combine green light with blue light, you get cyan. Now notice where they overlap, these are called the secondaries, the light secondaries. All of those are lighter than the light primaries. And that's because when light gets added to light, what happens? It gets brighter. Light is additive, right? So when you add all 3 lights together, how am I getting white on my projector right now? That's all 3 lights turned up at 100%, you get white light. How do I get black? How do I have black on my slide right now? That's where all the lights are turned off. So that is the light primaries, RGB color. Because it's light, we see all the variations that overlap between them. Everything within the human visible spectrum between infrared and ultraviolet. So light is the best way for us to see color. But we can't reproduce light. So when we want to make prints that are full color, we're limited to not light, because we can project it, but we can't reproduce it, right? We can't make a physical thing. So we have to use pigment. Pigment is pure powdered color mixed with some sort of binder. And what we use for most reproductions is ink. So that's kind of an oily, clear binder that dries permanent, and it holds this pigment. And they can be dye-based pigments, or they can be molecular-based pigments. So whether they're a chemical process that can see the color, or whether it's just the color of the molecule and how it filters light through it. But the best inks we have to match the millions of colors, we can get only thousands of colors in physical prints, are using these secondaries. Because these secondaries, if you're familiar with painting, are the primaries for pigment. So you can think of them as the pigment primaries, or the ink primaries, or the paint primaries. They are cyan, magenta, and yellow, right? Remember, black and white are not colors. So instead of having a black screen with no light, turning on all the lights to get white, and then mixing them to get the colors, printing has white for the paper, and then to get black, you mix all the inks at 100%. The problem is when you mix all the inks, cyan, magenta, all the colored inks, cyan, magenta, and yellow at 100%, you get what looks like black, but it's really just kind of a muddy brown. So it is very easy to make black pigment. It's one of the earliest pigments to humankind. You just use kind of charcoal or lamp black, kind of an oil, burnt oil, because carbon gives you that black. So we just add a black ink to this to make our prints a little bit stronger. So even though there's only 3 pigment primaries, we add black, and that gives us a lot more range of visible color if we can mix black into these 3 primaries. Notice when you mix the primaries of pigment, like cyan and magenta, you get the blue. If you mix cyan and magenta in equal measures, you get the blue that is the light primary. And notice that the blue is darker than either cyan and magenta, because this is subtractive. As you add pigments together, less and less light is reflected off of them. So they get darker and darker. Same thing with the green, which is mixing cyan and yellow. Same thing with the red, which is magenta and yellow. So Superman's cape, when it's printed, is 100% red, which means it's 100% magenta and 100% yellow, printed on top of each other. Now, when you print on top of each other, though, that would just give you kind of a muddy look. So offset printing is where the dots are printed in this very mechanically precise way so that they never fully cover each other up. So there's always a little bit showing. We've talked about offsets before, like how you can show something behind your image so it shows up on a dark background. Offset printing means the dots are all lining up on each other in a slightly different way. So it can give us the illusion of tone, and this is just one color ink. This is yellow and black ink on white paper. But it gives us the illusion of lots of tones within that range, right? So it looks like waves. Here we just have 3 colors, no black. And there are artists that use this kind of separation but don't separate it into dots, right? So these are silk screens where you're just using solid color printing with different opacities of ink to create, in this case, animations that are from physical printouts on cardboard. And if you want more information about it, these are all Behance links that you might get fascinated by. And they kind of go through the process of these artists, right? So it takes lots and lots of separate color filters in order to get the illusion of full color. Now, you'll notice that all those colors are just flat and solid. That's because they're not separating them into the dots. So let's talk about how the separating into dots happen. And this is all happening in the 20th century, right? Inspired by painters that did this at the end of the 19th century in something first called divisionism by George Seurat, later called pointillism, using pure color but optically mixing other colors when you put those pure colors next to each other. So the Ben Day dots, which is named after illustrator and printer Benjamin Day, is meant to closely space the dots so that they mix at a distance, but up close they would look like they're offset from each other. And this can work with black and just give you the appearance of tone, even though each black dot is a solid black, right? It's about using the space in between the dots to give you the illusion of tone when you're at a distance. Same thing with color. There are different ways to make the dots, right? We're going to be talking about halftoning. This is mechanical color separation. It's the easiest to understand, the easiest to reproduce. But with computer algorithms, we can create what's called index color separation, which gives us equally believable variations in tone, but in a way that's not as mechanically understandable. Sometimes it's just called a sand diffuse pattern because it just looks like grainy and sandy. But halftone is what we're really familiar with commercial printing. It's how our textbooks are done. It's how most things are